want that. Okay. Good morning, everyone. Let's check the chat here. Looks like we got some people here. Happy to see you guys. Happy Friday Eve. That's what this is called for those of you who don't know. I hope things are going well with your assignment and the other things that are happening in your life. I see many of you are getting started on the assignment. Some of you have finished. Is there anything that you guys want me to talk about regarding assignment 1 before we get into some more class stuff today? Please let me know. So usually what I like to do is I like to go through our notes from the previous day. I just kind of read through them a little bit at the beginning of every class to remind everyone what we talked about last time. So I will do that. And after that, we're going to continue on learning about classes today. I do have the next assignment ready. At the end of class, I may be able to give you a kind of an idea of what we're going to be doing there. I'm still working on the PDF to upload, the instructional PDF, but that will be uploaded today, at least by, I'd say, 6 or 7 p.m. I'm going to try to get it done sooner than that. But like I said, I'll give you plenty of time to work on that assignment. So, if that is all, then I'm going to go ahead and get started. Let's just head back up to the top here and see what we talked about last time. I'm trying something new today. I'm going to have the notes here on VS Code instead. I think overall it makes it a little bit easier to read. So I hope you're okay with that. And then this way I can kind of, I guess the only problem is that VS Code has an unlimited width. So it can kind of come over here, you know. But that's okay. Since I upload these notes at the end of class, I think you guys can live with it. Good morning, Secro. So the first thing that we talked about last time was function overloading, right? And the basics of a function overload is any function that's within the same scope. That's kind of something that I want to mention here. Doesn't go there, but it just means that you guys should be familiar a little bit with what it means to be within the same scope. Meaning, you know, if we had a function called, what were the examples we did? I think we did plus. If I had a function plus within a class, and I had a function plus that was global, that wouldn't necessarily be considered a function overload because they have different scopes. The example we went over yesterday, all of those plus functions were declared globally. And so it happens that they were function overloads. So they're all within the same scope. They have the exact same name, but they have different parameters. Now, I misled you guys yesterday. I kind of got caught up on that int float thing. So I'm just going to address that a little bit. And I did post a link in the Discord for that. And this part's really confusing. It's confused me for years even. So we're just going to touch on it a little bit. But since it's not the main focus of this class, we're not going to have it on any tests or anything like that. So downcasting and upcasting is something to consider, but it will not appear on your tests. And like I said, you'll talk more about it as you get into CS 326, 460, and stuff like that. So floats actually can represent a larger range than integers, though it's oddly confusing because both use 4 bytes, and they can hold the exact same amount of information, at least the amount of it. Let's see, so we have a question here. Let me address this. If it has a different number of parameters but the same name, it is still a function overload. That is correct. Let's see if I can clear that up anywhere. But different parameter list. So the different parameter list means, you know, it could have a different number of parameters. It could also have different parameter types. That's the example that we went over yesterday, where we did different parameter types. But if it has different number of parameters, it is also still considered a function overload. If we kind of look up here as well, we talked about constructors yesterday. Notice that these are constructors, so I'm not going to call them function overloads, but they have the exact same name, though they have different number of parameters. So yeah, you are correct. So just quickly back to this float thing. They hold the same amount of information, but somehow floats actually represent a larger range than integers. And so the way it does that is the float actually reserves some bits for like a power. So it might be 3.4 times 10 to the 37th or something like that. And because the float is representing or reserving some bits for the power of the number, it actually can make a much larger number than an integer. Though the thing to consider is floats do not always have the best precision. I don't know if you guys have ever experienced this before. You will at some point, but you might say float x is equal to, say, 5. And then when you see out that x, you'll see this. Something like that. You're like, why did you do that? That doesn't make any sense because I said you're 5, not 5.00001. Well, actually, floats have kind of holes in them. So the range is larger, but like I said, they hold the same amount of information as an integer. And so actually, floats have absolutely no way to represent 5 exactly. But the closest they can get to it is this 0.0001 thing. So in a way, int float could be considered an upcast, but it's still in a way unsafe. And then I'll just show you quickly in the Discord. I added just a little link about that. It's a really goofy example in which they pretend that you could make a new data type that has only 4 bits. And so here they say you could have an unsigned integer, 4 bits, and you could have foo4, which I think is 4-bit float. So the way that integers work is they're exactly, right? There's no decimal there. So it can count up like this. And the float has the exact same amount of information to store, except it has a bunch of holes somewhere. Where's the 1? Where's the 2? Where's the 3? It goes directly from 0 to 42. So read that if you'd like. But I needed to clear that up because I am an instructor at UNLV and I can't be feeding you guys lies. So I've corrected that and I hope you're okay with it. So I'm going to make sure that I kind of remove some things that were confusing. And I will just say this, that float to int and int to float are both considered to be unsafe. So that reviews our function overloading and our upcast downcast talk. Now we're going to come back to classes and data abstraction. So recall this concept of object-oriented programming. It's a programming style in which we're packaging both data, these are like our private variables, and methods or functions, whichever you call them. I kind of use them interchangeably. I guess I've been calling them functions, but just so you know not to get confused when I say something like that. In Java, oftentimes they call them methods, so just be aware of that. And what we're going to do is we're going to package them together, right? Some functions cannot work with certain data types, and so if we could just keep, only the functions that work with the data type all together, it makes for an easier kind of safe coding style. For example, strings. Every string has a length data type or a length method, a length function, which tells us how long that string is. We can call length on a bunch of other things, but maybe not an integer. And so that's kind of the idea there. We talked about data abstraction, which in a way we're just going to simplify some data types. We're going to hide everything that the data type shares, right? If we're making a car, we don't necessarily need to tell everyone that every car has 4 wheels. We kind of already know that. But what's different about the cars, right? What kind of horsepower do they have? What's the number of doors, the number of passengers that it can seat, things like this. Classes and structs. We've used structs before, right? What are some classes that we've used before? Well, here they are. Remember these. I like to ask this question on a test. Now, what is the only difference between a struct and a class? Well, the classes are private access by default, and our structs are public access by default. I gave you a direct example of that yesterday with some compiler errors. And then I tell you what an access modifier is, right? We can actually list in both structs and classes. You probably won't see this very often, but if you really wanted to, you could declare a struct P or something, and you could actually specify things to be private. And the compiler is okay with that. And that's because structs and classes are pretty much identical, except for that one small thing. So I list all these access modifiers. Remember that public members are access to all things, accessible to all things, and private members are only accessible to things within the class. So that's other class members, right? Such as the functions. I gave you some examples. We talked about what members are, right? Either a variable or function or constructor belonging to the class. And then we talked about this thing here called a constructor, which is where we left off, right? And I ask you, can we initialize members of our class as soon as the object is born? And that's when the constructor comes into play. So, in case you don't remember, constructors are like functions, and they return an object of that class. They return it, right? It's only called when an object is declared or allocated, which we'll get into later. So here in this example that I've listed, this is an int. If int was a class, the int constructor would be called at that moment. Strings are classes, so the default string constructor is called as soon as that string comes to life. And then string G here, notice that we specify this. We want this to be new string. This also calls a constructor. And this is exactly where we left off. Constructors are always the name of the class. And if there is no default constructor defined, the compiler will make one for us. And lastly, the default constructors will never take any parameters. So that's pretty much it for what we talked about last time. So we're going to go ahead while I still have your minds fresh. If you haven't fallen asleep already, we're going to be talking about some more notes here. I'm going to put some more notes down before we get back into the code. So let me pull up my notes here, and I've got my chat there. All right, so what we're going to talk about now is we're actually going to come up before this constructor bit, and we're going to just start talking about methods, okay? Methods, functions. So what are we talking about? We're talking about class functions, also known as methods, okay? So the first thing that I want to say is there a rule of thumb for using a class or a struct? Why would we use a struct over a class? If they're almost exactly the same, does it even matter? And in a broader sense, no, it doesn't really matter. But we have a general kind of coding style for this. And so this is our rule of thumb. This is also a test question I like to ask. Structs are used when we only have data. Okay, these are the variables. So you notice in assignment 1, we had an Olympic event, and in that struct were only variables, nothing else. The moment that we want to bring functions in, that's when we use a class. So classes are used when we want to have functions too. Okay, so that's our rule of thumb. And as you can see here, in this point 2D, we're starting to pull in some constructors. We've got some functions here, set x, y. We've also got these functions here. And so now that we have functions, we should probably be using a class. Now recall that member functions, they are part of the class. Thus, they have access to the private variables, right? That bit was maybe a little bit confusing yesterday. But that's kind of the whole point of having private variables. If variables were so private that nothing could touch them, then why would we have them? So that's why we have member functions that belong to our class. In general, member functions are usually public, though it's not always the case. Later this semester, I'm going to pull out one of my favorite assignments, and you'll see that I make some functions private. And that's just because the function may be kind of dangerously altering our private variables, and I just don't want anyone to have access to that member function. But in general, they're usually public. Let's see what's up next here. So, just kind of on the sense of talking about these private variables, right? I say if a member variable is private, what kind of functions do we use to access them? So there's kind of two types of functions for this. So there's kind of a read-only option. There's a read-only option. We usually call these getters. These are getter functions, okay? So you notice here I have get x and get y. These functions return a copy of that variable, right? In a sense, it's read-only. Right, if I come down here and I say int y is equal to p2.getX, and then I say y is equal to, say, 3, we're altering only a copy of what this was. We're not actually touching p2's x. So that's what we call a getter. And then we also have read-write. So oftentimes we'll call these maybe setters. And so you notice yesterday we made this function here, set xy. So we maybe call that a setter. And within the setter function, we can kind of control exactly how we want people to alter our private variables. So now we're going to introduce this concept of a mutator. Mutate means change, right? If you ever watched X-Men, we have mutants. I think that term mutant comes from like a changed human, right? So we're talking about mutators. So a mutator is a function that changes our object. So let me ask you this question. If you're looking at just these three functions here, which of them is a mutator? we have these three functions here. It's either setxy, getx, and gety. Of those three, which is the mutator? Cherry says setxy. That's correct, right? Now this function is a mutator because notice that it's altering our private variables, right? Our private variables are up here. They belong to our object, and this function is mutating. So this is a mutator. Now these down here are non-mutators, right? These are not changing our object at all. So we have this fun little thing that we can do. So what about our functions that are non-mutators? Now some of you might ask, I'm guessing you don't. Can we enforce that? Can we enforce that they're non-mutators? Can we say, like, no matter what, I don't want this function to mutate my object at all? And we can, and we use a const keyword. If a member function is constant, it cannot change the object. So I'll give you a nice example of this with this same example that we're working with from yesterday. So these guys down here are the non-mutators. So I'm going to add const to the end of this definition here. And I'll put an example in there so that we can remember that. Here's a good example. I'm going to copy it into our notes. So if you want to reference that, this is the exact same thing that we're doing today, right? So there's our constant. That's our non-mutator function. And so as this code is now, if I pull up Bobby here, it will compile as expected because that function is not changing anything within our object. But in fact, if I change it to do something like that, the compiler will enforce that this function is constant. So I know that probably didn't make much sense. My English got a little tied up there. But let me show you what I mean. So I'm going to pull over classes 2. I'm just going to show you that it compiles as is. We're working with classes 2 here. And everything compiled just fine. I'm not going to run the code because you've already seen it. But let's pretend that in here, before I return to X, I'm going to change the formatting of this so you can actually read what I'm doing. There we go. What if I said X is equal to 10? So this makes the function a mutator. But notice here that this is constant. And so actually the compiler is going to stop me. Look, it's even telling me right now that it's bad. It says expression must be a modifiable L value. Now I don't know what that means. We'll see what the compiler says. But Cherry asked the question here, const goes after the function name. Yes, that might be confusing because you've probably made variables before that are like const int x. And so you're probably sufficiently confused. And you have every right to be. But yes, it goes after the function name. So I'm actually going to pull this back into Bobby, and I'm going to compile it just so you can see it. And the compiler will be like, hey, that's not cool. So look at this. It says assignment of member point2dx in read-only object. Right? And that's because our function is constant. Let's see. Okay, so Ali asks, is that why you set the Olympic events vector as constant in the count distinct athletes method? So we wouldn't alter the original vector and only change the new vector. That is 100% correct. So oftentimes you will see, sometimes we'll pass in parameters as being constant. especially if they come with pass by reference, right? You'll see there's that little ampersand. And so that means we're actually passing a copy of it. If we enforce that parameter to be constant, that means we can't change it at all. So that's exactly what it does. And it's kind of a safe way to code. It is a safe way to code. So recall what this const thing is and remember it because it will pop up on tests and maybe your homework. So next we're going to talk about something very confusing, and I only say that to scare you. It won't be too bad, and we're going to have a nice example with it. So we've talked about this term static before, right? We talked about this term static, and so how I'm going to call this, let me see if I put something here. Static, I'm going to refer to these as static members always. Ali asks, if we use getters and setters, can we alter it then since it would only be altering a copy of it and not the actual thing? So let me pull up the skeleton code. We can talk about that. That's a good question. There it is. All right, so here we're on assignment 1 again. I'm going to go find one of our functions that we've done. All right, here we go. All right, so notice here in the print events for athlete. And you'll notice here that we have this parameter, and there's two things about it. The first thing is this ampersand. That ampersand means it's passed by reference. This is not SQL. Means we're actually getting the exact memory location of events, right? The second thing is that it's const, which means it's unchangeable. So if you tried to do this, if you tried to say events.pushback or something, and I could just say, I don't know, notice we're going to see this red thing here. And the reason this is because this pushback function is, it is a mutator, right? It's not a constant. It's not a const member. And so if this happens to be const, we can only call const member functions from this object. Now, if you wanted to edit it, you would have to do this. You would have to say exactly this thing. And then you could say copy.pushback e. So please tell me if that makes sense. This events thing here is literally only a read only. It's literally, English is not my strong suit. It is only read only. And that's all it can be. If you wanted to make a copy, you would have to specify it down here. On the other hand, if this was not constant and we didn't pass it by reference, then we would totally be able to edit it. It would already be a copy, so we wouldn't have to worry about it in that case. And so we can come back to that if you need. You're welcome. So now we're going to talk about static members. Now these are not static variables. And it means something very, very simple. A static member means that there will only be one for all objects That means one memory location for this variable or function. So static member functions have access to other static members, but not, we call them instance variables. Let me put a definition for that. An instance variable, or a member, is a member belonging to an object. So that's an instance variable. So if we go actually look at classes here, X and Y are instance variables because there's one for every instance of this object. So P is an instance, P2 is an instance. So P has its own instance variables, X and Y. P2 has its own instance variables, X and Y. Static means the complete opposite thing, meaning there's only one. And so these static member functions will have access to other static members, but not any instance variables. And so we'll talk about that. I'm sure I'm sufficiently confusing you. But it's time for example. It's example time. So let's talk about static members. Static members. So we're going to start with a static variable, and then we'll move on to a static function. So let's start with that. Static variable. I'm going to call this the static int point count. Static means there's only one for all instances. Cherry asks, instance variables are what we've been using. That is correct. The X and Y variables are instance variables. These are the instance variables. This is a static variable down here. Notice that we've specified it to be static. Now, this is confusing because this point count will be changeable, right? So it doesn't mean static in a classic sense, right? This can be changed. And it only means that there's one of them. For all class objects, there's only going to be one of them. Because there's only one of them, where are we? We need to initialize static variables globally, or in the outer scope. Because there's only one static variable, we need to initialize it globally. So this is going to be a little bit confusing, but we'll come back around to it at the end of class. So I cannot do this. This is not allowed, and you will see errors in your code. Okay, look, it's even telling you here, this is not okay. So if it's a static member variable, it needs to be initialized globally. Don't get too hung up on what I'm about to do here, because it's going to look like nothing you've ever seen before. But it will never change from this. And I'll tell you exactly what I'm doing later in class, like I said. But here I've initialized this point count globally. And so we'll kind of talk about this. So check this out here. Maybe I want it to be public for now, so it's easier for us to access. And let's say that this, excuse me, let's say that this point count, it's going to keep track of how many points we have in our program. So every time a constructor is called, right, let's go ahead and increment that point count. Please tell me if what I'm doing doesn't make sense logically. Point created, increase the count. You should be okay with that. Yes, you are. And so there's another constructor there, right? Thank you, Synchro. So every time a point is created, we're going to increment that point count. It's kind of like a global variable in a sense. And we can actually figure out what's going on with this static variable as the program's running. So for example, I'm actually going to delete this stuff. This is a new program, so I don't need any of that stuff. We're only going to focus on this static variable part for now. I might as well introduce this thing now, and I kind of want to talk about it later, but I can't really do it properly. So I'm going to talk just quickly about the scope resolution operator. So the scope resolution operator, it's pretty simple. It's an operator and it looks like this. And all it does is tells the compiler which scope to look in. So I'll kind of explain to you what I've done here. Notice on this static variable I have these. This is the scope resolution operator. Now there is no, if I did this, it would be okay, but this point count is a global point count. It actually doesn't, it's not the same point count as this one. And so by using a scope resolution, I can tell the compiler to go look inside of the .2d scope. The .2d scope is from this first bracket, or that last bracket, to this one. So everything inside here is the .2d scope. And so I'm telling the compiler to go look inside of that .2d and find that point count. So what I'm going to do again is use this .2d scope resolution operator. I'm going to say cout, there are this many points. And so I'm going to go look in that .2d scope, and then I'm going to reference the point count. And then I create a point, and I'm going to do it again. And then I create another point, and I'm going to do it again. Let's see, I've got a question here, but I lost my mouse. Cherry asks, since we are initializing it, we also have to include the data type. Yes. So this is something else. At the end of class, I'm going to talk about how we can define these outside of the class. This is almost like a function definition in a weird way. So we have to include the type here. Always remember that. If it's a static thing, static variable, you always have to include the type. So let's run this code, and you'll see that this point count is going to go up one by one as we call our constructors. So let's go take a look at that. Let's go take a English JP. English. All right, so where we are today. Here we are. My computer's having a moment. You may not be able to hear me right now, but I'm just going to let my computer breathe for a second. Let it catch up on what it needs to. And we'll let Bobby contemplate its life. All right, here we go. So we're going to run our code. And so you'll see here that how many points were there at the beginning of the program? Well, there were 0. Are we all back? I'll give you guys a second. That wasn't my internet. That was my computer getting backed up, bottlenecked or something. All right. So I'll continue on. I guess some people didn't disconnect, some people did. Thank you for telling me. So what I've just done is I have compiled and run the code. TWG, I'm sorry about that. But if you ask a question, I'll always go back, I promise. So you'll notice here that at the beginning of the program, we initialized this point count to be 0. Right? Here it is. It's initialized to be 0. And so at the very beginning, when we printed it out, it was 0. And then I printed it here, right? So that's where it was 0. And then I created a point, right? And notice we called the default constructor. And so inside that constructor, we incremented our point count. And now there's 1 point. Then we created another object here. This one went through the parameter constructor, but it did increment the point count, and now we're at 2 points. So as you can see, this static variable is operating independently of any of the objects, right? It's operating independently of any of the objects. There's only one of them. And so I just want to be clear about this. You can access static members from objects. Okay? So if I wanted to, notice here I have the point count. I could say p2.pointCount. Now I hate this. It will compile and it will work as you expect it to. In a way, you're going inside of P2's scope and looking at all of the variables that it has access to. Now I hate this because to someone who's never read the code before, they may think that this point count belongs to P2, which is not the case. It belongs to the point class. It belongs to all of the points together. So in this case, it kind of looks like a static or an instance variable. This looks like an instance variable. So if you ever want to access static members, I'd much rather prefer you do it this way by using a scope resolution because this is confusing. At least it is to me. So now we're going to do one more example of a static member function. So here we go. I'm going to make a member function here. It's going to be static int add points. And this add points is going to take in 2 objects. It's going to take in the left-hand side object, and it's going to take in the right-hand side object. And so what will this do? Well, it will return an object. And the way we're going to do it is we're going to take the left x plus the right x and combine it to be with the left y plus the right y. Does that make sense? So look at this. I'm going to call a constructor. I'm just going to declare a brand new, actually this is not an int. I'd rather have this return a new point. So I'm going to add the 2 points together and I'm going to return a new point. So I'm going to declare a brand new point 2D. I'm going to call this probably the return point. And I'm going to go ahead and just call a constructor with it. I would like to call the parameter constructor in which I'm able to pass in what I want the values to be. Well, what will our values be? It will be the left-hand side x plus the right-hand side x. And then it will be the left-hand side y plus the right-hand side y. Now, guess what? Notice that this function has access to those private variables. This is okay because this static function belongs to the class. So don't be confused here. This is a function that belongs to the class. Therefore, it has access to private members, even if the members are passed in as parameters. This is a point2D class. This is the point2D class. At least this function here is. And so it's allowed to come in here and alter these private variables. It's completely allowed to do that. So now I'm just going to return it. And then we're going to have a little fun here, trying to figure out what our compiler did. You guys are going to help me solve a puzzle here in just a moment. I'm not going to do that yet. I kind of want to come in here and I want to say point 2D, maybe our third point here, P3. And I want it to be, say, equal to, I'm going to call this static function, right? So it's a static function, so I'm going to go in here and I'm going to use our scope resolution operator. And I'm going to call add points. And I'm going to pass in P and P2. Maybe I'll call this P1 just because it would make my life a little easier, I think. So Cherry asks, the left-hand side X are the variables we already made before. In a way, yes. So look at this. This is a static function, right? This is the one that we just declared. And notice that P1 was defined up here. So P1 has its own X, right? It has its own X. And so then later down here, we call add points and we pass in that P1. So we'll come up here. And so P1 is now the left-hand side parameter, right? So this X here is P1's X. Can you tell me what this X is? What is this X? Or what object does this X belong to? Based off of this down here. I just want to make sure that we understand what is happening here. P2, exactly. Right, P2 is passed in as the right-hand side parameter. And so here it is, that's P2 right there. And so this X belongs to the P2X. Or this X belongs to P2. Right? So I hope that's, I mean, maybe not clear, but clicking a little bit. So here we're going to make a third point. The data type is point2D, right? Yeah, there's a little bit of like inception going on here. All right? This is the class point2D, and then in here I've got all these point2Ds. It's a little bit of codeception, right? And then I'm going to see, well, first I want to see what are the values. Well, what are our values? So I want to see, say, p3.getX and p3.getY. Now, it's going to be 0 plus 2 and 7 plus 0, right? So P3 will be 2, 7. But then, we're going to do this. We're going to see how many points there are. And now it's puzzle time. So prepare your engineering brains. See if we can figure this out. Oh. That didn't do at all what I thought it would do. Never mind, I guess there's no puzzle to be solved. Abort. Don't worry about it. But I can make a puzzle happen later. So notice here, we declared P3. Oh, no, we didn't. A parameter constructor was called somewhere, right? Where was that parameter constructor called? Here it is. It was called right here. Here's the parameter constructor, right? And so notice that that's where it's called. And then we say P3 is equal to this. And then now there are this many points, right? There's 3 because we called the parameter constructor. So now I'm going to make the puzzle, guys. I promise this time. I'm making another constructor, okay? Making another constructor here. This constructor is going to be codeception copy. This is what we call the copy constructor. Now, it may not make so much sense why we need a copy constructor yet. See, Cherry says, for the static function, why did you use the dot operator? Here, I did not use the dot operator. Could you specifically tell me where you're referring to? And hopefully we can figure it out. What does this say? The one in the class. Are you saying here? So, I don't have to use the dot. I mean, I am using the dot operator to access the instance variables of these parameters. But I actually don't need to use... Is that what you're asking? That I'm using the dot operator here? And the reason for that is because this function is taking in 2 objects, 2 different objects. And these objects have their own instance variables. So if I say x here, actually, look at this. I'm actually glad you asked this. Let's say I do this. Can you tell me what does this x belong to? The IntelliSense is telling us that it's bad. But does this x belong to anything? Secro says no. Are there any other opinions? Cherry says, oh, I'm happy about that. Little Attacker says no. I think that's good. That's a good assumption. All right, guys. So this x, what is this x? This x belongs to nobody. Why? Can anyone tell me why this x belongs to nobody? No, it's all good. I'm sure there's still some people, though, that this is making no sense. So I want to ask, why does this x not belong to anybody? Yeah, so both objects have x's, right? So that's fair. But the main reason is that this is a static. The answer that I was looking for is that this is a static member. If we go look at our notes, where is it? There's only one for all objects, right? There's only one for all of the objects. And so since there's only one, that means that there's only one add points. And therefore, this function doesn't have an x. Doesn't have an x. So this x belongs to nobody, and that's because it's static. If this was not static, it would have an x. But it is static, so it does not have its own x. I even kind of said that here in the notes, that static members have access to other static members, but not any of the instance variables, right? So there's no, this is an instance variable here, but it does not have access to it. It has to go inside of an object and find it. So Ali asks, how does it know to set the P2 left-hand side and the right-hand side points as the Y? So this here is a, can anyone tell me what I'm calling here? What is called here? At this moment, I call something and I'm asking the class to tell me exactly what's being called at this moment. I'm declaring a point 2D, so something happens. I can even kind of pull up the terminal, right? Look at this output. Is there something that happens there that refreshes your brains? TWG says a constructor, right? That's what's called. So to answer your question, Allie, I declare a point here, right? This point is now born. So since this point has now come to life, a constructor is called. Which constructor is called? Well, I specify this as this, right? If I can put these in parentheses for you to kind of give you the idea that this here is just an int, and this here is also just an int. So what constructor matches int? If we come up here, you'll notice here that this constructor here takes in both an x and a y. And exactly what happens when that's called, well, you'll see that we call this set xy thing. So let's follow the, I guess, calling order. We create P1, this is a 0, 0. We create P2, that's 2, 7. And then we call add points, okay? So at this point, we're doing a 0, 0 plus a 2, 7. So we pass in P1 and P2 to this function, and we come up here. And I declare a brand new point. And in the constructor, I pass 0 plus 2. And in this, I pass 0 plus 7. So it's 2 and 7. And this constructor is then called. So we go up here. This is 2. This is 7. We print out the param constructor. That happened, right? Here it happened. And then we call set xy. And what does that function do? Well, it comes in here. This is 2. This is 7. And it says x is equal to 2. Y is equal to 7. That's kind of complicated, though, right? That's a big convoluted thing that happened there, right? There's a constructor called here. That's how it knew to do that. There's a constructor called there. So now I'm going to introduce the copy constructor. And it's just going to take... Yeah, you're welcome. The copy constructor just takes another point2D as a parameter, okay? So this is the copy constructor. And the compiler will force you to make this a constant in a sense that it doesn't want you to be able to alter the other object, okay? But this one's easy. We'll just say x is equal to the copy x. Wow, is this confusing or what? And we'll say y is equal to the copy y. Are you confused yet? This is the instance variable for our object that we're making. And then these x's belong to the copy object. There's also one thing I want to do. Let's do it this way instead. This is the copy constructor. Thank you, guys. Copy.x. This is the copy.y. So we'll do it exactly the way we've been doing it. Yeah, the names do confuse you, right? All right, so now the puzzle's going to come in, okay? It's time for the puzzle. So I'm going to call the copy constructor. So TWE says copy being a blueprint of some sorts. I would say yes. That's correct in the sense that this is already an object that exists. It's already an object that exists, but we're going to use this to initialize a brand new one. Okay, so this is the copy constructor, and it says, when you're born, I want you to be an exact copy of this one. So please tell me, does this line of code confuse anybody? It's a little convoluted, but I ask you, what does add points return? Add points returns a point to D, right? So this thing is going to be a point to D, and I'm going to ask P3 to be a copy of this point to D. Whoa! Puzzle time. All right, guys. I told you there'd be a puzzle, so now we're going to do it. Let's look at what happened here. What the heck happened here? All right, can we see what's going on here? I think so. All right. So we all know what happens here at the beginning, and then we get to this line of code here specifically. I know you can't really see the rest of it, but this is where we call add points. It's also where we create this brand new point P3, right? So we call add points and we call the copy constructor. So you notice here that a copy constructor is called, a copy constructor is called, a parameter constructor is called, and then how many points are there? There's 5? I thought there was only 3 points. Right. So you're seeing it, right? You see how many points are? Well, that's as many constructors that are called, right? The default constructor, the parameter constructor, 2 copies, and then another parameter constructor. 5 points, but there's only 3, right? There's P1, there's P2, and there's P3. Does anyone, just by looking at this line of code, does anyone have an idea of where those copy constructors happened? We know that this here is the parameter constructor, okay? We know that this is the parameter constructor. But where did the copy constructors happen? And then we can fix it. I'll just give you a few minutes. I know it's a hard puzzle. We've never seen this before. But it's an important concept to understand. Cherry says when I called it in main, kind of okay with that. Oh, well, yeah, so this, in a sense, this is one of them, perhaps. I'm not exactly sure what the compiler did, but here, I'll give you a hint. So Ali says, why wouldn't there be 6? I think you're right. I think you're right. I think there should be 6. Ali got it, though. She's exactly right. Do you guys see this? What is this? This is pass by value. What happens when we pass by value? Is this the original one? Or no? This is a copy. This is a copy of the original one. What happens when we do a copy? Yeah, right? Swag says there, it makes a copy. What happens when we copy it? That's what happens when we copy it. Don't say that. That's a copy. So I'm not sure why there were not 6. Ali, I think that there would be 6. So I'll take a guess at why that maybe happened, but I definitely think it should say 6, not 5. Because here we call a copy constructor, and then it passes in P1, P2. It says this is not pass, it says this is pass by value. So it makes a copy of P1, it makes a copy of P2. So it should be copy constructor, copy constructor, copy constructor. And then it should say parameter constructor. But I'm guessing the compiler knows at some point that this calls the parameter constructor instead. So for some reason, it skips this one. And I'm not sure why it does that. And I'm mad at the compiler for doing that. I think it did some automatic optimization there. It said, this add points calls the parameter constructor. So in a way, I'm going to make this be the parameter constructor. Something like that. But as long as you guys understand that this called the copy constructor and this called the copy constructor. Does anyone know how we can fix it? How we can fix it so there's only there's only 3 points. And I gave you the hint, right? How do we fix it? Give you a few more seconds here. You need to get some Jeopardy music. Someday I'll have it. But then I might get DMCA'd, and I don't want that to happen. Secro says reference. Yeah, now they're all flooding in. These don't make copies anymore, right? These are the originals. These are the originals. So let's see what happens now. Ha! We fixed it! Does it make sense? I hope that makes some sense. These constructors can get, like I said, convoluted, right? But we fixed it. So there you have it. There you have it. And maybe I want these to be constant because please don't change them. I don't want you to do that. Don't change them. I like them the way they are. Ali says, can you explain why pass by reference could avoid the copy but pass by value doesn't? So recall this. Where's my little pic? Where's my little picture? Come here, picture. I think Internet Explorer is better for this. Did it finally open? Here it is. Do you remember this? Can I zoom in, please? Please zoom in. I guess I can't zoom in on this. Yeah, Explorer being better is definitely rare. The cups, though, okay? It's a little small. But notice in the pass by value, what happens here? The cup that's in the parameters is a copy. It's a copy of the original one. And so how does the compiler make a copy? How does the compiler make a copy of that cup? It calls the copy constructor. If it's a pass by reference, it's passing the memory location of the original one, so it doesn't need a constructor at all, because the object already exists. Does that make sense? That to do a pass by value, it has to make a copy of the original. And how does it do that? It calls the copy constructor. So where are we now? How are we doing on our notes? All right, we're getting there. Yep, we're almost at the end, guys. I'm so happy. We're doing it. We're doing it. So now we're going to move on to a little something different. So come back to your constructor minds. And please tell me if I need to go back for anything, okay? We're doing a lot today. Please tell me if I need to go back for anything. So what is this? What is a destructor? All right, Ali's responded here. Let's see. Pass by reference doesn't use any constructors. That's 100% correct. You're passing the old one. You say, I already have this one. I'm going to give it to the function. Constructors are used to make objects in general. So look at this. This constructor is used to make a brand new object with no parameters. So this constructor is called here. This constructor is used to make an object with predefined parameters. So that constructor is called here. Then there's something called a copy constructor, which is this one, in which the parameter is another object. And so the reason that the copy constructor is called in this case when we do a pass by value, it's because that it needs to create some copies. And so it says, I need to call a constructor. Is there anything passed to the constructor? Yes, there is. It's P1 and P2. So in pass by value, the copy constructor is always called. Whenever you make a copy, the copy constructor is always called. In this case, the copy constructor should be called here, except the compiler realized that I call the parameter constructor here, and it said, meh, I don't want to help you make your point to the class, so I'm just going to kind of ignore that part. But I hope that makes sense. Constructors are called to make brand new things. And if a copy is provided, then the copy constructor is called. So I said destructor. Does anyone have an idea of what a destructor is, or when is a destructor called? You can answer neither. You can answer one or two. I hope that it's kind of intuitive. I think the easiest one to answer would be when is it called? When do you think it's called? So I'll give you a few Jeopardy beats here. Synchro says at the end, right? I'm happy with that. That's a sufficient answer. End of main is partially correct. End of main is partially correct. Calls when the object goes out of scope. In simpler terms, when the object dies in a way, I don't know. If you want to refer to it that way. So let's look in main. Notice that this is one scope. You guys understand that these brackets here, this is the scope of main. This is the scope of main. And so when does P1, P2, and P3 go out of scope? It's right down here. This is when P1, P2, and P3 go out of scope. So all the destructors will be called right down where I've highlighted here. So destructors are like reverse constructors. There is only one destructor per class. So how many constructors can a class have? Plenty. I'm not sure if I included that. Classes can have multiple constructors. There can only be one destructor per class. And what does it look like? Has the class name with a tilde. I think that's how you spell that, right? Just like flower petals. Please tell me if I spelled that right. The tilde is the button underneath the escape, right? And so I should have an example of that. Let me pull it out here. Thank you, Synchro. So this is kind of what we've been talking about, right? We talked about our total points or our point count. I do still need to go over that, but we'll get to it eventually. And here's the destructor. So let's go ahead and make a destructor for our class here. So these are our constructors. Here is our destructor. So I need a tilde, and then I need the point to D. That's our destructor. And we're going to say goodbye point. And then what else should we do here? Well, maybe when a point goes out of scope, we can subtract from this static variable. What do you say about that? Right? We're losing a point. So we can decrement. What's going on? Is that how we dance? I love that. All right, so there's our destructor. So let's go run the code. What do you say? Let's go run the code. Let's go run the code. I have to find it. Where is my code? Please work. Waiting on you, Bobby. Any day now. Whenever you feel like it. Thank you. All right, here we are. Here we are. Let's run it. Goodbye, point. Goodbye, point. Goodbye, point. Goodbye, everybody. When were those called? Well, it happens right here at the very end of this. So now, are you guys ready? Is there another scope in here that I've made? If so, where's the other scope? And tell me where the point goes out of scope. TWG asks a great question. Don't you have to specify which object is destructed? The answer for that is no, but it's already it's kind of obvious in the sense that if I declare this, we know that we're calling a constructor for P1. Whenever this P1 goes out of scope, it knows that the destructor will be called. So maybe this will answer your question, TWG. This P4, it's going to go out of scope here. So here's what a for loop creates a new scope, executes the body, closes the scope, and then does it all again. Ali says, how will it make P4 if there's no more constructors to build it? Well, this is the default constructor here. And let's run the code and let's talk about it. You're going to love this one. Let me do this. I love my lines. My lines are life. My lines are life. Here we go. We'll say. Good night, Moon. Good night, program. Hey. All right, here we are. Here we are, folks. So let's talk about this. Boop. Right there. Can we see it all? I think so. Yep. All right, that's good. So what happens? I is equal to 0. We create a new scope. And then we create a new object. P4. P4 is created. How is P4 created? Well, there's no parameters passed to it, so it calls the default constructor. We can see that there, right? So then at this point, how many points do we have? Well, we have 4 points. And then, guess what? It touches this little bracket here. It says end of scope. So now P4 is out of scope, and the destructor is called. Which destructor is called? Well, all of the destructors for every object that's going out of scope. So TWG, the only object that's in the for loop is P4. So which destructor is called? Well, the one for P4, since it's the only object within the scope. So P4's destructor is called, and then I is equal to 1. It creates a brand new point. So we see default constructor. How many points? Well, there's 4. Goodbye. Default constructor, 4 points. Goodbye. Does that make sense? I hope so. Just that the default constructor is pretty much called whenever you see either a bracket or a return. If you see a bracket or a return, it will be called. And I'll even show you an example of this. Let's take our edit back here. Up here. Let's say, you know what? No, I want these to be copies. So let's say that these are copies. So we should see a destructor called. Ali says, why didn't the deconstructor get called after P1, P2, and P3? So those destructors do get called, Ali, and they get called down here. So the reason they're called down here is actually that P1, P2, and P3 are all in the scope of main, and the for loop scope is actually within main. So P1, P2, and P3 are within scope of the for loop, but it's not their birth scope. Is that... I like that term. It's not their birth scope. What is their birth scope? Well, it's the main, right? So when main goes out of scope, then we'll see the destructor called for these objects. Point P4's birth scope is this for loop here. So whenever this goes out of scope, we'll see the destructor called for this P4. Now I'll ask you, reference line numbers maybe in this case. These are going to be called with copy constructors, right? Do you think there will be a destructor called for them, and where will it be called? What line number, roughly? Whoops. Give you a few Jeopardy beats here. I know that we're kind of behind, right? Cherry says 59. I'm totally okay with that. I would also say that 58 is an appropriate answer. 59, 58. The return happens on line 58, and that's when it goes out of scope anyway. So they'll go out of scope here, and we should see some destructors being called here. Listen. Little Legend of Zelda reference there. Hey. So when we see that, hopefully we should see some destructors being called. Unless the compiler decides to screw me again, but I don't think it will. I'm trying to teach these kids. You guys aren't kids. Here, see? Those are the destructors for the copy constructors. Are we lagging, everybody? Oh, gonna wait. We are having unstable connection. Oh, we're back in the green. Yeah, it should be good now. I can see my little green box. So you should be able to hear me. So now we'll continue on we've got 5 minutes left, so I'm going to kind of speed run this a little bit. And then you guys can go. So just notice the point here is that these were called with copy constructors. And the left-hand side copy and the right-hand side copy go out of scope here. And so the destructors are then called. Okay? So you guys should understand now what a destructor does. And then our final thing that we're going to talk about today is just declaring member functions inside and outside of the class. Since we're kind of running out of time, instead of typing it out, I'm just going to do some copy pasting. If you guys have any end of class questions that you've been thinking about, feel free to get started on those. But let me just finish this little bit up here. So when it comes to declaring member functions inside the class, this always is okay, and it works exactly the way you think. So if we come look here, notice that this function has been declared inside the class, and it works exactly the way you think it would. Meaning that you just add brackets onto it, and it works, right? Now recall when it comes to main, right? This is our assignment. Up top here, I can put all of our prototypes. Here's all of our prototypes. And at the bottom, I can put the definitions for those functions. Can we do something similar with classes? And the answer to that is yes. So once again, I'm going to do a little copying. I mentioned this earlier today, right? I said I'd come back to it, and we need the scope resolution operator. So you will need to use that. You will also have to put the prototypes in the class. So I'll give you an example of this. And it's good to do this because then we can keep our class readable. And you'll see in the assignment skeleton code, I do exactly this. So let's pretend that I didn't define this. Well, we won't start with that one. Let's start with this one. Let's pretend that I didn't define this class inside, or this function inside the class, and I just have this. If I want to define the definition below somewhere, I will say, well, I'll put my body here. But I also say void. It works exactly the way you might think, in that you could just copy this and put it here, except it thinks that this is a global function. And so what you need to do is you need to grab this point2d and you need to put it there. And then now you can define the function outside of the class. And so we could do that with literally all of these. For example, I'll do it with the default constructor real quick. Can anyone tell me what outside of the class would look like? Notice you have to include the type here. Cherry, before you asked about this int thing, right? Why do I have to do it? Well, it's kind of the same thing as this. It's treating it almost like it's a member function. And whenever you put the definition for a function, you need to include its type. So if I wanted to do the constructor out here, what do you think it would look like? We know that the constructor has this name, but the constructor has no type. We're kind of running out of time here, so if you're typing it at this point, I'm sorry, and I don't mean to steal your glory, but it will look like this. Okay, so notice I just put the, yeah, Cherry got it, right? Didn't mean to steal your glory, I told you. So it works exactly like that. Okay, so that's what the scope resolution is. So I give a nice example here, and in the assignment, you will be kind of doing that. So that's it for today. We pretty much covered everything for classes. We barely slid in there underneath the wires, so I'm happy that we did that. An assignment is going up tonight. Just look for it if you want to get started. I will go over it tomorrow. I'll hang out here for 5 minutes if anyone wants me to touch on something. And thank you for coming to class today. As always, you guys make my day. It's my favorite part. I'm always happy to see you guys. Let's see. So we have a question here. Since we have classes now, we can choose to make those functions inside the classes or outside, right? The answer to that is yes. But I will show you the skeleton code for the next assignment, just real quick. And sometimes you don't really have a choice because I make you do it this way. If you're having errors, I usually won't be mad if you put it in there, if you decide to move it. But our next assignment, we're working with playing cards. So this is a class for a playing card. Look how nice it looks. Doesn't it look so pretty? I think it does. And then when we come down here, we can then just put all of our definitions in here. So you have an option always, Cherry, but for the upcoming assignment, I'm going to make you do it out here. But look, I already kind of included it for you, so you won't have a chance to practice it yet, but you'll get to in the future. So I hope that answers that question. And now we've got a question here. Allie says, in regards to count distinct athletes, would you recommend using a copy of the Olympic events so loop through and compare the names? So for those of you who maybe are struggling a little bit with that, I'll give you just an idea. I would make a copy in a sense, okay? So you're going to have this vector of events. Now let's pretend that your list is Bob, Jack, and Linda or something, and then maybe another Bob. So this is your events array. And what I would do, if you want to do the ID, so Allie, you're welcome. I would do the ID. Do the ID. I kind of put a little thing about that in the, if you want, I'm sorry to confuse you. If you want to match my output exactly, do the names. But if you do an ID, it'll be slightly off. All right, so I won't mark you if you choose them, but to match my output, do the names. So you have your events array, which is this. And then you have, let's say, a new array, the names array. And let's say it's empty to start. And so this will be kind of your first for loop here. For, say, I. And then in here, you're going to have a second for loop, say, for maybe j. And so for when I is 0, you'll say, hey, have I seen Bob before? Well, let me check my names array. And so for all the names in the names array, are any Bob? Yeah, no problem, Synchro. Have a great day. Are any of them Bob? Well, my names array is empty, so there's no Bob in there. So I'll say, who? Here we go. Bob. Cherry, I did answer that question, I think. Your max, it's okay if you're, as long as the value is the same for the max value or the min value, it should be okay. Whichever, as long as the value is the same. The event might be different, but the value has to be the same. So here we're going to put Bob in here, and then we're done. So then we're going to move on next to this Bob. So I is now equal to 1. So let's go check our names array. And in our names array, let's look through it. Do we have a Bob? Yes, there's a Bob. So we know that we're not going to insert it. So then we move on to Jack. We're going to check our names array for Jack. Let's see, is it in here? Bob, that's not Jack. Is there anything else? No, there's not. So we'll put Jack in there. So then we'll come back up here. What's the next one? Linda. We come into our names array. Is there a Linda here? No. Is this a Linda? Nope. We're done. So the Linda goes in here. And then finally, we're going to look at Bob again. We'll come in here. Is there a Bob? Look, I found it, so we won't insert it. So that's kind of a rough idea of what that algorithm might look like for you. You will use 2 for loops. But if you're going to talk about using events, you're going to have your vector Olympic events, and then you're probably going to have a vector string names array. Does that answer your question, Allie? Or does it give you kind of an idea of what you might be doing? You live down there? You want to say hi to everybody? I'm sure there's a few people that are left in the stream still. Yeah, it'll be uploaded. I don't think it'll be laggy. Okay? So just check the YouTube video. And that's that. So for everyone who's still here, I hope you have a great day. Loaf says goodbye. And I will see you guys tomorrow.